Volcanoes. Just the word evokes images of fiery rivers of lava, towering ash clouds, and the raw, untamed power of nature. They are a window into the heart of our planet, a reminder that beneath the seemingly solid ground lies a world of immense heat and pressure. But how do these geological marvels actually work? What forces drive molten rock to the surface, creating these spectacular and sometimes deadly displays? The Earth's tectonic plates are always on the move, but their pace is incredibly slow. We're talking about centimeters per year, about the same rate your fingernails grow, but over millions of years, these tiny movements add up, rearranging continents and creating some of Earth's most dramatic geological features, including volcanoes. Now, imagine two tectonic plates meeting head-on. Neither wants to give way. The pressure builds, and the rocks begin to melt, forming magma. This magma, being less dense than the surrounding rock, starts to rise, seeking a way out. It accumulates in magma chambers beneath the Earth's surface, like a pressure cooker ready to blow. The type of volcano that forms depends on several factors, including the type of tectonic plate boundary and the composition of the magma. The birth of a volcano is a dramatic event, a testament to the immense forces at work within our planet. As magma rises from the depths, it carves a path through the Earth's crust, creating a conduit known as a volcanic vent. This vent acts like a chimney, allowing magma and gases to escape to the surface. The first eruptions are often the most violent. Think of uncorking a bottle of champagne that's been shaken vigorously. The pressure release is sudden and explosive, sending a shower of molten rock and ash high into the atmosphere. As eruptions continue, the volcano begins to take shape. Lava flows cool and solidify, building up layer upon layer, creating the iconic cone-shaped mountains we associate with volcanoes. But not all volcanoes are created equal. Their shape, size, and eruptive style depend on the type of magma they produce. Let's explore two of the most common types: shield volcanoes and composite volcanoes. Shield volcanoes are the gentle giants of the volcanic world. They are characterized by their broad, gently sloping sides resembling a warrior's shield lying on the ground. These volcanoes are formed by eruptions of highly fluid lava, which flows easily and spreads out over large distances. Imagine pouring syrup onto a plate. It spreads out in thin, runny layers. That's similar to how lava flows from shield volcanoes. These flows can travel for miles, slowly building up the volcano's distinctive shape over time. Because the lava is so fluid, eruptions from shield volcanoes are usually not explosive. They're more like a slow, steady outpouring of molten rock. Think of the Hawaiian Islands. These islands are actually the tops of massive shield volcanoes that rise from the ocean floor. Mauna Kea, the tallest mountain on Earth when measured from its base on the seafloor, is a shield volcano. These volcanoes are a testament to the power of persistent, gentle eruptions over millions of years. In contrast to the gentle giants of the shield volcano world, composite volcanoes, also known as stratovolcanoes, are known for their explosive tempers. These majestic mountains are characterized by their steep conical shapes and their potential for catastrophic eruptions. Composite volcanoes are formed by layers of alternating lava flows and pyroclastic deposits. Pyroclastic deposits are a mixture of hot ash, rock fragments, and gas that are blasted into the air during explosive eruptions. These eruptions are much more violent than those of shield volcanoes, sending columns of ash and gas high into the atmosphere and creating pyroclastic flows, which are fast-moving currents of hot gas and volcanic matter that can race down the volcano's slopes at hundreds of miles per hour. Think of Mount St. Helens in Washington State or Mount Vesuvius in Italy. These are both examples of composite volcanoes. Their eruptions can be incredibly destructive, burying entire cities in ash and mud flows. The 1980 eruption of Mount St. Helens, for example, was the most deadly volcanic event in the United States. When volcanoes erupt, it's truly a show of force, a dramatic display of nature's raw power. Volcanic eruptions are among the most awe-inspiring and terrifying displays of nature's power, capable of altering landscapes and climates. They are a stark reminder that beneath the Earth's seemingly solid surface lies a world of immense heat and pressure, capable of unleashing unimaginable forces that can reshape the environment. The type of eruption a volcano produces depends on the composition of the magma, which can vary greatly. Magma with a high silica content tends to be more viscous or sticky, making it harder for gases to escape. This viscous magma traps gas, building up pressure until it's released in a violent explosion, sending ash and lava high into the sky. Think of shaking a can of soda and then opening it. The pressure builds up and then explodes outward. The pressure builds up and then explodes outward, much like a volcanic eruption. On the other hand, magma with a low silica content is more fluid, allowing it to flow more easily. It flows easily, like the syrup we talked about earlier, moving swiftly across the landscape. This type of magma allows gas to escape more readily, resulting in gentler, less explosive eruptions that can still be quite destructive. But regardless of the type of eruption, the effects can be far-reaching and devastating. Ash clouds can disrupt air travel, grounding planes and causing widespread delays. Lava flows can bury towns and villages, destroying homes and infrastructure. And pyroclastic flows, with their scorching heat and speed, can incinerate everything in their path, leaving nothing but devastation behind. Famous eruptions have left stories etched in time, shaping the course of human history and the natural world. Throughout history, volcanic eruptions have left an indelible mark on human civilization, influencing cultures, economies, and even climate. From the catastrophic eruption of Mount Vesuvius that buried the ancient city of Pompeii in 79 AD, to the cataclysmic 1883 eruption of Krakatoa that sent shockwaves around the world and altered global weather patterns, these monumental events serve as stark reminders of the immense and often unpredictable power of volcanoes. The eruption of Mount Vesuvius is perhaps one of the most well-known volcanic events in history, capturing the imagination of people for centuries. The eruption buried the Roman cities of Pompeii and Herculaneum under a thick blanket of ash and pumice, preserving them in time and offering a unique archaeological treasure trove. Today these ruins offer a haunting glimpse into Roman life nearly 2,000 years ago, frozen in a moment of disaster. Another infamous eruption was that of Krakatoa in 1883, which had far-reaching consequences. The eruption was so powerful that it caused a series of devastating tsunamis, killing tens of thousands of people and reshaping coastlines. The sound of the eruption was heard thousands of miles away, making it one of the loudest sounds ever recorded in history. The ash cloud from the eruption circled the globe, affecting weather patterns for years to come and leading to spectacular sunsets worldwide. These are just two examples of the many volcanic eruptions that have shaped our world, each with its own story and impact. They serve as a reminder of the raw power of nature and the ever-present potential for change. Understanding and respecting these forces is crucial, as they continue to shape our planet and influence our lives in profound ways. Volcanoes, architects of our planet. These fiery giants have been shaping the Earth for billions of years. While volcanoes are often associated with destruction, they are also creators. Their eruptions, though violent, pave the way for new beginnings. Over millions of years, volcanic eruptions have played a vital role in shaping our planet, creating new land, enriching soils, and even influencing the Earth's atmosphere. The very ground we walk on has been molded by these natural forces. Remember those Hawaiian islands we talked about earlier? They are a perfect example of volcanic creativity. They were formed by volcanic eruptions over millions of years. Each eruption added layers of lava, gradually building up the islands we see today. As magma rises from the Earth's mantle, it creates new crust, pushing the ocean floor upward and forming islands. This underwater activity is a continuous process, unseen but ever-present. This process is happening all the time, slowly but surely creating new land. The cooled lava forms the foundation for future ecosystems. Volcanic eruptions also release gases into the atmosphere, including water vapor, carbon dioxide, and sulfur dioxide. These gases have far-reaching effects on our environment. These gases have played a crucial role in shaping the Earth's atmosphere over billions of years. They contribute to the greenhouse effect, which is essential for maintaining the planet's temperature. For example, water vapor released during volcanic eruptions is thought to have contributed to the formation of our oceans. Without these eruptions, our planet might look very different. Volcanic ash, while initially destructive, breaks down over time, releasing nutrients into the soil. This process enriches the land, making it more fertile. This makes volcanic soils some of the most fertile on Earth, ideal for agriculture. Farmers around the world rely on these rich soils to grow their crops. So, while volcanoes can be destructive in the short term, they are also essential for life as we know it. Their contributions to the Earth's landscape and atmosphere are invaluable, supporting diverse ecosystems and human life alike. Volcanoes are a powerful reminder of the dynamic forces that shape our planet. They are both creators and destroyers, capable of unleashing unimaginable destruction, yet also responsible for creating the very land we live on. Understanding how volcanoes work is essential for mitigating the risks they pose. By studying their behavior, scientists can better predict eruptions, giving people time to evacuate and minimize the potential for loss of life. But beyond the scientific importance, volcanoes also hold a certain awe-inspiring beauty. They are a testament to the raw power of nature, a reminder that we are but temporary inhabitants on a planet that is constantly changing and evolving. So the next time you see an image of an erupting volcano, take a moment to appreciate the awesome forces at work, shaping our world for billions of years.